Greetings, Dr. Will here. Welcome back to the serialization of What You Don't Know, Successfully Lead a Software Project Without Tech Expertise. Episode 24, Chapter 10, Will It Even Work? How Will We Know? Quality Assurance and Test, Part 2.
When there is a culture of quality, every individual within the organization cares personally about the quality of the product. High-performing agile teams internalize that culture. Arguably, all high-performing teams do. There are 4 factors in creating and sustaining a culture of quality. First, leadership emphasis, where leaders impress on managers that quality is a priority. Managers should then be expected to walk the talk on quality and make it a priority in evaluating employees and contractors. Second, message credibility. That means that quality messaging appeals to the workers personally and is delivered by respected sources. Like any effective communication, the messaging must be consistent and easy to understand. Third, peer involvement is needed, where the culture is just management slogans. Employees or contractors have a network of peers that provide help and guidance. In a quality culture, peers hold each other accountable and actively discuss quality on the team. Finally, ownership. The workers need to be empowered to make quality decisions and are comfortable with raising concerns with management about quality violations or questioning edicts and directives that conflict with quality goals. On the flip side, watch for these 10 indicators of a weak culture of quality. First, the CEO and senior executives rarely discuss quality or performance against quality objectives. Second, the company's quality vision is either non-existent or has minimal linkage to business strategy. Third, the organization has few, if any, feedback loops for continuous improvement of processes. Fourth, employees are not familiar with the company's quality vision and values, or perhaps worse, view them as mere slogans. Fifth, new hires are not formally introduced to the organization's quality vision and values. Sixth, managers either fail to consistently emphasize quality or are resistant to quality initiatives. Seventh, the company lacks formal mechanisms for collecting and analyzing customer feedback. Eighth, metrics used for performance evaluation feature little to no mention of quality goals. Ninth, training and development do not emphasize quality. And finally, 10th, organization experiences frequent, perhaps minor setbacks owing to inconsistent quality. Mistake proofing, poka-yoke. More literally, avoiding yokeru inadvertent errors, POKA. This is usually an automatic device or method that either makes it impossible for an error to occur or makes the error immediately obvious once it has happened. The concept was formalized and the term adopted by Shigeo Shingo as part of the Toyota production system. This should operate on 2 different levels at once in every software project. First, it should apply to the software process itself. The SDLC should be as mistake or idiot-proof as possible. Also, the software product and its process artifacts, requirements, design, and code should ensure that the software product being built helps the software end user avoid mistakes. Any well-engineered system works this way. This should be a fundamental, even if unstated, requirement when developing a system. Particular places to be vigilant. First, a process step where human error can cause mistakes or defects to occur. Second, a handoff step in a process where output is transferred to another worker or another part of the system. Third, places where minor early errors cause major problems later. Fourth, where the end user can make an error that affects the output. Fifth, where the consequences of an error are expensive or dangerous. The system should never allow the user to end up in an oubliette. That is, using the application should never result in the user arriving somewhere in the application that cannot be escaped. No way out. Drums in the deep. A situation where the only solution is restarting the application. Technical debt. A high-fidelity MVP, depending on how high, delivers real value to the customer. The higher the fidelity, the more real the value. But you have to manage the technical debt. A system's technical debt is the implied cost of additional rework caused by choosing an easy, limited solution now instead of using a better approach that would take longer. Technical debt is incurred when the system's maintainability is ignored during the development of the product. The idea is that the product delivers real value that the customers will be willing to pay for, and with enough revenue there will be plenty of largesse to fix the problems later. If the system is running well enough and the technical team hangs together, then an if it ain't broke, don't fix it mindset will forestall investment to pay down the technical debt. The chances are good that short-term activities of implementing new features, driving more sales, and resolving urgent bug fixes will dominate any long-term solution to the technical debt. And if not, There's a hazy landscape littered with zombie companies staggering around from quarter to quarter. Not enough revenue to fix the problems, technical debt weighing down their valuations, but with too many customers, employees, and hopes riding on them just to bury them. Don't be a zombie. The trick with technical debt, like any debt, is to get far enough ahead of the curve to pay down or off the debt. If you don't, then eventually it could eat your project. The rising development and integration costs owing to the increasing difficulty of adding new features and resolving unresolved defects will result ultimately in dissatisfied customers who will look for alternatives. Churn. Quality assurance, quality engineering helps manage technical debt. Incurring technical debt needs to be a conscious choice. Plan how it will be addressed and revisit it during each strategic planning session. Defect management. Because software is not defect-free, it is essential to be responsive to defects discovered by the customer. The support of the customer base is crucial to customer satisfaction. Tools are widely available to provide necessary automation for the deployed software. Reporting. The customer must be able to report a defect they encounter and the steps needed to reproduce the error. That last can be difficult because the user may not recall precisely what they were doing when they encountered the problem. Lacking specifics, any relevant information is helpful. Where the user encountered an error, what they were doing or trying to do, and any error messages they may have seen. Managing communication with the user about the defect should be done through the tool as well to keep all defect-related customer information together. At its best, the system will allow the reporter to check on the status of the error. Tracking. The error needs to be tracked and managed. It may be a user error that is handled directly with the customer and the help desk staff. Many user errors occurring in an identifiable part of the system suggests a breakdown of Poka-Yoke. If the defect reported is a software defect, it is tracked from its originating report through its correction and delivery. A reported defect is reproduced by the development organization. The steps needed to reproduce the error are critical here. These steps, plus any other similar actions also resulting in a similar error, form the basis of a test case that will be used to validate that the error has been corrected. Creating the test case should precede fixing the defective part of the code. The test case will be used during implementation to debug the code. The code needs to be fixed. Depending on the error, its severity and architectural significance, the documentation artifacts used to initially design or specify the code needs to be updated to reflect the necessary changes. The test developed that reproduces the error also validates that the defect is fixed and should be incorporated into the regression test suite. Future releases will then re-demonstrate that the defect is still fixed. The current regression suite is run, and if everything passes, then there is some confidence that the fix hasn't introduced any new errors. The fixed system is ready to be deployed to the user.
That ends Chapter 10. Will it even work? How will we know? Quality assurance and test. Join us next time for Episode 25, Part 1 of Chapter 11, How to Keep a Handle on It All. Criticality of configuration management. That's it for me, for you, for now. Be careful out there. Bye.